From breathing bear traps to moving pancakes to whatever the heck, turtles are some of the strangest creatures our planet has to offer. With 14 families and over 360 recognized species, turtles are an incredibly successful clade, living in freshwater and saltwater and on every continent besides Antarctica. Testudine is the title of the clade, which encompasses all turtles, which are sometimes also referred to as tortoises or terrapins. The label tortoise is often used to describe the terrestrial testudine clade, Testudinidae, and terrapin is a label often used for freshwater turtles, but can be misleading due to the fact that many terrapins are not closely related whatsoever.
As you can see, the clade splits into two main suborders: the Pleurodyra, or the side-neck turtles, and the Cryptodyra, or the hidden-neck turtles. The different methods of bending the neck require completely different anatomies of the cervical vertebrae. All extant turtles have 8 vertebrae in the neck, but cervicals on the Pleurodyra allow a large range of sideways movement, as opposed to the Cryptodyra, whose vertebrae are wide and flat.
This is a phylogenetic tree of the crown reptilia, otherwise known as sauria. As you can see, based on fossils, genetic, and morphological data, zoologists classify turtles in a clade known as Testudine, which is more closely related to the Archosauria, which includes crocodilians and aves, or birds, rather than the Lepidosaurs, which include the Tuatara and the lizards. And to answer your question, yes, birds are reptiles if you classify species by evolutionary relations. Like their reptilian relatives besides birds, all turtles are ectotherms, otherwise known as cold-blooded, meaning they rely on outside factors such as sunlight to regulate their body temperature. Turtles lie golf ball-like eggs, like the other reptiles besides the few that give live birth. Turtles, like crocodilians and squamates, have something called temperature-dependent sex determination. This means that the temperature at which the egg is incubated at certain points determines the sex of the offspring. All species of turtles, regardless of how aquatic, lie their eggs on land, like all other reptiles. Although some toothed turtles have been found in fossil record, all modern turtles have beaks, just like birds. What makes a turtle so unique is its shell. A turtle's shell is covered in cartilaginous scutes, keratin being the same material that makes up our hair and nails. A turtle has a carapace, which is the top of the shell, and a plastron, which is the bottom of the shell, which is connected through the shell's bridges. Now, the carapace and plastron is thought to have evolved from the turtle's ribs and backbone as a defensive mechanism. Because turtles' hard shell cannot expand to accommodate their lungs, breathing is accomplished by moving the muscles that are connected to the turtle's plastron, shoulder, and pelvic girdles. Now, when did the turtle shell evolve? Sadly, the history of the turtle shell is not well documented, meaning we have to speculate in many cases of how and when the shell evolved. Unitaurus africanus is the oldest known ancestor of the Testudine clade, having evolved over 260 million years ago in what is now the swamps of southern Africa. It had flat, broad ribs to support its broad forearms, which were most likely used for burrowing. Odontocalis semitessia, which evolved over 220 million years ago, had a fully developed plastron, which is speculated to have evolved from the ribs to protect from creatures attacking from below, since it was an aquatic species. Progontocalis, which evolved over 210 million years ago, is the oldest turtle to date with a fully developed carapace and plastron. And that is my coverage of the Testudine clade. In my next few videos, I will be describing the two suborders, Pleurodyra and Cryptodyra, in detail, starting with the side-neck turtles, or the Pleurodyra.